Welcome on our next Indeed session. Today the topic is gRPC, and my name is Tomáš Makala. So let's get started. Does anyone know gRPC, or has anyone used it before? Okay, probably not. It's not exactly a new thing, but it's been only getting traction in last few months or maybe a year or so. It's a high-performance RPC framework. So, in other words, technology that you would use to call systems within each other. And during this presentation, I will be comparing it mostly to REST, although it's not a direct competitor to REST because it's suitable for slightly specific use cases. You are all familiar with RESTful services, and so that way it will be easier for me to explain. So probably not the biggest, but one of the differences is that with REST services, we are usually using JSON or XML, which both are human-readable formats, but not very efficient from like a technical perspective. So gRPC, on the other hand, uses technology by Google called protocol buffers, which is a binary serialization format that I will explain later how it works. In general, it's not human readable, being a binary format, but much more efficient, both encoding and decoding, which is one of the reasons why gRPC is in general more performant than your regular REST service. Also, unlike REST, it's built on HTTP2, which is like it's a part of the specification and it's required. Yeah, there is no fallback to HTTP1. So if you're working in an environment where HTTP2 is not available, either because the end devices don't support it, or the network is configured in a way that it only allows HTTP1, then you can't use it. Yeah, there's no workaround for now. REST, on the other hand, may or may not use HTTP2, but even if it does not benefit from it much because it was something like added later. Yeah, but it wasn't designed in a way that it could actually use many of the features that HTTP2 offers. gRPC works on many platforms. Currently, according to their website, it should be those that you see there: Android, Java, C++, C#, Dart, Go, Java, Node.js, Objective-C, PHP, Python, Ruby, and there is also a limited support for web browsers. As of today, most scenarios should work, but there are some technical limitations that cannot be overcome by the technology itself, because the limitation lies in web browsers, that they don't allow you to do certain things with the underlying HTTP2 connection. And for this reason, one of the features that doesn't work on web is bi-directional streaming, which I will be showing in a while. Apart from these languages, there are many unofficial ports, so chances are that it's available even for your platform if it's not listed here.
Yeah, it's not. Some features don't work in JavaScript. It's work in browser and you use WebAssembly.
Yes. That's why they. I think that's why they list Node.js and web as two separate items. Because, as you say, the problem is not in JavaScript, but in the browser.
No, technically it's in JavaScript, because you can host in browser WebAssembly code, which uses its own implementation. It's working fine.
I see.
I've seen some examples when they run WebAssembly in browser and everything works fine through GPRS. Just by the way.
Okay, I didn't check it. Maybe that was the reason. It also have native support for certain features that you can simulate using REST APIs, but it's not really built in. Whereas here it is. And one of these advanced features is streaming, There are, well, 4 modes how the communication can look like. The first one, it's actually, I'm not sure if maybe I shouldn't have put it here, but it means no streaming. In this mode, it works like a normal web request response based communication, yeah, where the client initiates the communication and the server responds. But with gRPC, there are other modes as well. You can stream from client to server, which means that, again, the client initializes the communication and then sends a stream of messages. And when the client says, that's it, then the server sends back a response. It can also work in opposite direction, that there is just one initiating request by the client and then the server sends a stream of messages. So far, these 3 things are achievable with REST APIs quite easily, but then there is also bi-directional streaming, which would be very difficult to implement otherwise. Same as in the other modes, it's still the client who has to send the very first request, yeah, because obviously it's not possible for the web server to talk to just any browser on the internet. It has to be the client. But once the channel is created, both the client and then the server can send messages simultaneously, and it's not like request response anymore. It's like 2 independent streams, each flowing one direction. There is also some built-in support for authentication, although I'm not sure what they meant by that, because for example, they mentioned SSL certificates, which can be used for server authentication, but that's natural. It's based on HTTP2, so of course you can use SSL certificates to authenticate the server. One thing that is there, though, is built-in support for client certificates as well. So you can use SSL certificates to, instead of, let's say, JWT tokens to identify individual clients. But since if you ever worked with client certificates, you know that it's quite painful. So I was wondering how hard would it be to actually implement something that is like easier to work with, such as those JWT tokens. And based on my demo, I wouldn't call it really like a built-in feature, but it's easy to do, as you will see in a while. Yeah, because I was trying to do something a bit more complex than a Hello World scenario, so my Hello World actually has authentication. Credentials can be handled in 2 ways. Either it's per channel. Channel is well, something that you create between the server and the client in order to exchange data, or you can have different credentials per each call within that single channel. There is, or for me, one of the biggest selling points of gRPC is that it's built around contracts. If you are designing a REST API, then the mental model usually looks in a way that you design the service itself. Then you want to publish the contract somehow, so you can use a tool such as Swagger to generate some contract definition. And then on the other side, you need some, either you create the client manually using the Swagger definitions, or you use some tool that does it for you automatically. But the problem is that there is quite a few things that might go wrong in the process. Whereas here the approach is different, and you actually start creating the API from that contract. And the very same contract you then use to create skeletons of both the server and the client implementation. This is actually one of the 2 services that you will see in my live demo in a while. It's a chat application where you have a server side, and then you can have multiple clients that send messages to each other. And in this demo, I have 2 gRPC services. One of them, this one, the authentication service can be accessed anonymously, and its purpose is to log you in. Yeah, you send in your username and your invitation code, and it returns either success, in which case you get back an authentication token, or a failure, and then you would have a string with a reason of that failure. So this is how a definition for such a service would look like. It starts there with the service keyword, and you can see there that it has one method called login, which takes login request as the DTO that goes in and returns login response that you see there. And there, notice this one-off keyword. This is sort of a pattern matching. Yeah, and it says that the login response, based on how it went, can return either login success, for which you have a definition here, or login failure defined here. Also notice that for each attribute, for example, the username, invitation code, you have to specify index of that property. That's because of how the message gets serialized, which I will explain in a while. So just keep that in mind. But let's move on for now. And this is the second service of our chat application. On the previous slide, I have omitted a few lines to keep it simple. So, this what you see here, this is the complete service definition, the same one as in the source code. Yeah, this is basically, I just needed to add this syntax equals proto3, because currently there are two versions that you might work with. That's proto2 and proto3, and unless you define proto3, it falls back to proto2, which typically you want to work with the newer specification. Then you can reference multiple protobuffer files between each other using those import statements. So in this case, I'm using this import to import a message type of timestamp that I'm using here. And as I said, you use the same contract to generate clients and servers on different platforms. And for this reason, you have an option to specify some metadata that helps the generator to generate the code in a way that is easier to use. So for example here, since my demo is written in C#, but don't worry, I've tried to do it in like a really straightforward way so that you can follow even if you don't work in .NET. So here I'm telling the compiler that when it generates the client, I want it to be in gRPC chat.contracts namespace. I could put a similar option for, let's say, Java, PHP, and other languages in the very same file, so that I can still have just one file for any technology I choose to use for this implementation. So what do we have in this service? It's slightly more things here. For start, we have two messages. One is send message, which again takes message to send. Where is it? Message to send here, which contains just a string, basically what you type in the console, and it returns a send message, so that you can print it into your own console as well, which has a timestamp edited by the server side, and you as a sender. Well, nothing interesting here, but look at the second one. That's actually a stream. It's called subscribe, and the idea is that once you log in, you subscribe to all incoming notifications. Also notice that subscribe request goes in, but it returns not just a notification, but a stream of notifications. Yeah, which means that you will be receiving some number of notifications, which again might be one of the three types. It might be either a send message, if somebody sends a message in the chat room, or it can be a mention. That's I added this feature that you can type a message and mention other user using this add character. Like if there is an Alice and Bob in the chat room, Alice can type like blah 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 at Bob, and it mentions Bob.
What does it mean, even there? One of the even.
It's a if you use this pattern matching feature, you need to name the like the envelope for the messages. It does not need to be event. Yeah, I could name it like how I want it.
One more time. What does it mean?
Well, you have a message not called notification, and within that message, you have one property called event. It can have any name you want. It doesn't matter. I just call it event. And then the event is one of those three types, depending on what has happened in the chat room.
And repeated, what does it mean?
Repeated, it's basically a list. Yeah? It means that, yeah, because you can, using this add character, you can mention multiple users. So this is how you would define a list. Yeah, so there is one person who made the mentions, and then there is a list of possibly multiple users who have been mentioned. There is also support for enumerations, as you see. So if you are getting back a notification of type user event, which is defined here, then you have a username that the notification is about, and user event type, which can be that the user either joined or left the room. So now let's look at the live demo. As I said, it's in .NET, but I tried to keep it simple, so I hope it should be possible to understand. So I have a solution here with three projects. One is the client, the second one is server, and then I have contracts shared between the two. So now I have the two protocol buffer files with this .proto extension. And those are the very same that you've just seen. Yeah? So I would go them through again. Let's look at the client instead. So as I said, first since the chatting service is protected by a JWT token, our first task will be to get the token somehow. So, or maybe even better, let me just show it in action, and later I will explain the code. So this is the server side, and there we have a client. And now let me launch two more clients so that it's more interesting. Good. So first we need to log in. So let's say we have Alice in the chat, and in order to log in, she has to provide an invitation code, which is hard coded to 1, 2, 3, 4. If I put there something different, then the service will return one of the options that you've seen in the one-off statement. So in this case, it's a failure, and this is this invalid invitation code. That's the fail reason. So if I try again and provide a valid invitation code this time, I should get logged in, and the same I can do for these two more clients. So let's say we also have Bob there, and one more simple name. Let's have Grzegorz. And now all three clients are subscribed to my notification stream. So now if Grzegorz sends a message, yeah, they should get it via that stream. He can also mention someone using this add character. So Alice, up. and there I would get this other people would get a notification that they have been mentioned. Yeah? So if it was like a real graphical application, it could shake the window or something. Here it just prints it in the console. And there is also some lifetime management. So when Grzegorz left, the other should know via another notification. So that's all for the demo. It's all it can do. Now let's look at the implementation. So as I said, it all starts by the contracts. And so, once you have this contract defined, you can use it almost automatically. This is let's start with the client. Yeah? I've split the logic into two parts: authentication strategy and chatting strategy. The authentication strategy, that was the part when I was entering username and invitation code. So let's look inside. And this, first we need to create the channel. Yeah, that's the thing that we use to exchange data between the client and the server. And if you don't need to provide any credentials, then it's really easy. And you create it. Oh, actually, that's it already. I think I thought that there is some more code behind it, but actually it's just that. Create anonymous. It's just this gRPC channel for address. Server address, and if for the other service I will need to pass in a JWT token, which, as I said, I wouldn't call it a built-in support, but it's easy to do, and you can do it by adding an interceptor to all the calls. And here in the interceptor code, you just say that you want to add a metadata, which are basically HTTP headers, and this is how the HTTP header would look like. It would just say authorization bearer and the JWT token that you have received earlier. So once I have the channel, I can call methods on it. Or, well, actually, first I need to create a client on top of that channel. And in this client, I'm using a client definition that Visual Studio created for me automatically. I assume if you use other technology stack, or like at the background of all of this, there is a compiler called Proto-C that you can call from a command line, and it generates output in different languages. And I assume that's what Visual Studio is doing automatically if you add this .proto file. So if you use some other technology stack, you will probably want to have it as a part of your Webpack or something similar. Here it's actually super simple. As I said, when you add this file, it just creates this protobuf in your project definition, and since that moment it just works. And if I made a change into this proto file definition, it would recreate the client automatically on first successful build. So this is my logging logic, and I know that we need to send in a login request, which has a username and an invitation code, which I read from a console. That's the thing that you have seen in the demo. And here I'm just calling this login async method, for which I get this response, and based on the response type, here you can see how can I check for the result of this one-off statement. So there is this result one-off case, and it's either a success or failure. So if it's success, I know that there will be this JWT token present, And if not, then at least I have a failure reason that I will print into the console. And that's where the authentication strategy ends. And from that point on, I have this chatting strategy, which again, it creates a channel, but this time it creates it using this JWT token. So it will include this HTTP header into requests. And here I create a client, but it's a different kind of client. It's chat service client, which is the one that is built upon this definition instead. And here we will subscribe for the incoming notifications. Yeah, I needed to do it in a separate thread because otherwise you couldn't listen for notifications and type new messages at the same time. So it's actually running on the ground here. So I just called subscribe and got back a subscription, which is my stream that I can hook on. And each time there is a new message, I can process it somehow, basically as you see here. Yeah, either it's a message sent notification or a mention notification or a user event notification. And in all three cases, I just print them in the console using my helper methods here. On the server side, it's also quite simple. I will skip the ASP.NET Core specifics because it might not be interesting for most of you. I will just show something that should look like, you know, the concept should be similar in the clients for other technologies as well. So I will focus on that. So this is my authentication service, which was again pre-generated for me. I just needed to append basically this part, yeah, the actual logic. And again, if I modified the .proto definition, then this base class that I used to define the server would get regenerated automatically as well. So it would be easy to, let's say, add another method to it if I wanted. So anyway, here we are getting the login request. And what we are doing here is that we're just verifying the invitation code, and if it's the one that we expect, then we will create this login success response and set the JWT token there. If it's login failure, then instead we will create this login failure message and just return it. Yeah, I imagine this would look very, very similar in any of these supported technologies. Chatroom service has one part that looks different, and that is this subscribe method. Yeah, you also have this send message, but that's still the same. Yeah, you just get a request, generate a response, and send it back. Nothing interesting here. But here in the subscribe, you can see how do you work with streams. Yeah, so here again I can hook on the stream, and as long as the method runs, the channel should be open and I should be able to send messages back to the client. Yeah, so I'm using this get consuming enumerable, which basically blocks my queue of notifications until there is a message available. And as long as I'm blocking here, the stream is kept open, and I can still append data to it using this response stream.writeAsync. There is also this cancellation token that gets triggered when the client leaves the chat room. So when I pressed Ctrl C, it generated this cancellation token event, and so this an exception gets thrown here. And here I just knew that the user left, and I closed the stream. That's all. So before I move on, do you have questions for this implementation part? Okay, so let's.
Do you plan to replace our slave in this?
I hope not, but let's see.
At least it have some history, so I think it would be improvement.
Until you close the server.
It's hard to be worse than it's not.
So one thing that you need to think about when designing APIs is backward compatibility when you make changes to the API. With gRPC, it's a binary protocol, so keeping backward compatibility might be a bit harder than it would have been with REST APIs that use JSON as a serialization format, but it's possible. You just need to follow and understand a few principles that I will demonstrate right away. So let's say there is a restaurant that for some reason has an open API that you can use to make a table reservation. And when you do so, you need to provide a customer name, how many people, and your email address. But it turns out that it's not very practical to use or to contact the customer via email. So the restaurant decides to ask for phone number instead. So in other words, they would like to remove the email address, add a phone instead, which is also a type of string. And then they also want to add this special wish, which is like an upsell opportunity for them. And all of that without breaking the existing clients that have been generated using the previous contract, which didn't know phone, had email, and didn't have this special wish. So how should we do that properly? A naive way would be just, there is an email, but we want a phone, so you just rename email to phone, and you add another enumeration special wish, and the enumeration looks like this. Looks good, but actually this wouldn't end up very well. And to understand why, let me explain just briefly how the protocol buffer serialization format looks like. So when you are sending a message, let's say it's the same message with customer name, person count, and email. It serializes it in roughly like this. It iterates through all the attributes, and for each of them, it starts by this index of that attribute and its type. And then it's slightly more complicated than what's shown here, but basically, first 3 bits of the first byte of each attribute represents like a var type. It's called var type of the message, which is like a type that is used to serialize the data. So for example, I know that for string, the value is 2, hence 0, 1, 0. And the other 5 bits are the integer number of this attribute. So in this case, 1. So if you sum it up, then in decimal, it's 10. So we put it here. And then since it's string, the deserializer on the other end knows that the first byte that follows after this header is the string length, which is 5 characters, Alice in our case. And there you have Alice. And the same goes for other attributes. So then we have the person count, which is number 2, so it would be 0, 0, 0, 1, 0. And the data type for integer is 0. So it should be 16. And then you have number 4 as the value. Also notice that although this is int 32, so you would expect 4 bytes to be there, it's actually just 1 byte. And it's because the format uses like a variable length numbers. If the number was, or it works in a way that if the most significant bit is set to 1, it means that the number continues by the next byte. So for number 4, it's easy because it fits into 1 byte without utilizing the last one. If the number was bigger than 127, then it would need to do some binary magic to it to actually encode it. Well, and so on. Yeah, and then again you have email, which is number 3, so that would be 00011, and the type is 010, which is 26. a string of length 5, and then this is the a at b.c.
Customer name starts with the index 1. Is it possible to use 0 as an index or not?
I'm not sure if you can use 0, but you can use any number. Like it doesn't have to be like in order, like 1, 2, 3. Yeah, it can be 8, 27, 70.
Biggest number is the 5-bit number.
Actually, I'm not sure because maybe it can do this binary magic even to this these headers.
Okay.
So maybe it can be more. I'm not sure. So now, with this knowledge, how should we fix the refactoring that we messed up earlier? So first of all, we now know that it's not enough to rename the email to phone, because as you've seen, there is no identification of the property name on like in the data that gets transferred over the network. Yeah? It's just the index. So if you keep the index and just rename the fields, then the old clients will still send the email addresses, thinking that that's the right thing. So what you need to do instead is to remove this line, this email equals 3, and add a phone, but at a new index, which is 4 in this case. You also want to be sure that we don't reuse number 3 for anything else in the future, for which you can use this reserved 3 keyword. And with this in place, if I used some other property and assigned it an index of 3 again, it would fail during the compilation. Now, about this special wish. So obviously it should have its own index, for example 5, but there is one more feature for the serialization part that I didn't mention. The message that you've seen, it can be even more compact because the format omits attributes that are set to its default value. So for example, I had people or person count equal 4, I think, but if it was 0, then it wouldn't be present in the message at all, because it's something that can be derived at the receiving side. You don't really need to specify it explicitly. But what does it mean for our enumeration? If I had a birthday cake equals 0, it would use that as the default value. So all the clients built against the old contract definition would be requesting a birthday cake automatically, which probably isn't something they would typically want. There is a convention that when you are adding an enumeration, it should have a default value, which must be 1. You can have an enumeration without this 0 value. And it must be something sensible. So in this case, it would be none. Is it understandable? Okay.
Do they have Boolean or it's a noun with 2 options?
I think there is Boolean as a specific type. Okay, so we're getting to the final use cases for gRPC. I think, and that's also what I've read, that it's suitable for mobile devices or in general devices in the wild with possibly poor network connection, because it benefits greatly from HTTP2, because it's enough to create just one channel between the client and the server on the TCP level, and the message multiplexing is then made inside this single channel between by HTTP2 itself. It's also a good fit for microservices, because for microservices you usually have, let's say, if you host them in Kubernetes, then the best practice is to have some internal network where you don't even need to use authentication, because you know that nobody else can get in apart from your microservices. And also, it's an environment where you can guarantee that both the end parties for your API and the network infrastructure can support HTTP2. Similarly, it can be used for back-office applications, because that's also like a semi-controlled environment where you can make sure that it will be configured in a way that you need. On the other hand, for me, it's questionable if it should be used for customer-facing web applications, because as I said, there is no fallback from that HTTP2. And as of today, I've seen a number somewhere that around 40% of traffic on the internet runs on HTTP2, but it might not be enough, yeah, depending on nature.
Why do you think it's blocked on some firewalls or proxies or?
Well, normally it's not, but if you have large enterprises, then they may have like overly smart firewall that is doing some deep packet inspection, which means that
I
it's.
know HTTP2 here is for a long time. I guess everybody are prepared.
Well, I don't know. I heard it's about 40% of internet traffic, which isn't that much. Yeah, definitely.
Yeah, because people don't use it because a lot of applications are very old, almost ancient. So I don't know. I think that usually HTTP2 shouldn't be the issue, but
well, maybe.
I don't have numbers.
Actually, I wanted to try some JavaScript demo as well, but I didn't manage because it's quite time consuming to prepare those indeeds. So I don't really know, but what I heard, it's still not like fully ready for.
Yesterday I saw a demo for gRPC in Blazor. And it was quite straightforward. I used it wasn't based on you. I just saw it on interest and it was quite straightforward to implement.
Okay, well, maybe things have moved in meanwhile. So another questionable use case would be embedded devices. And although I said that it's a high performance RPC framework, that there is a lot of things that the device must be able to do, you know, like quite advanced encryption and other things to even support HTTP2. And for this reason, it's probably too much for microcontrollers. So it wouldn't be very suitable for that purpose. And also, it might not be very suitable for public APIs, but there the reason is different, and that it's arguably much harder to use than a simple REST API. So probably too much for many developers. So if you have just some simple public API where you don't even care for performance, then it will probably still make sense to continue using REST or something like that. So, and that's all. If you have any questions, then please ask, or here on, or maybe on Slack.
What about HTTP3? It's some idea how to potentially move to HTTP3.
I don't know. They only have HTTP2 now. You're too fast.
Yeah, there are some libraries for HTTP3. It's not standard yet, but it's like in beta version of standard thing. You know, it's,
I don't know. I've seen some discussion about like maybe porting it or providing a fallback for HTTP1, but nothing about HTTP3. So I don't know.
Yeah, because the performance of HTTP3 should be even higher, so it's interesting.
If you need to debug the not-working communication, are you using Wireshark for this purpose?
Well, I guess you would have to, because it's not human readable, so you would need to actually work with this binary data.
That's what I wanted to ask, if Wireshark has some support. How to read this binary data?
Well, basically, it mostly reads binary data, so...
I mean, if it can read and visualize it. In the human
well, probably not, because the data doesn't make sense without the contract. Maybe if you have the contract, then I can imagine there is a tool that can reconstruct them, but without it, it's just some binary nonsense.